everyone. So let's do today's daily LeetCode challenge question. Yeah, I'm streaming. Okay. I have not looked at this question before, so let's see. 1937 maximum number of points with cost. You are given m times n matrix. Okay. So I'm then given this matrix and what? It is a matrix points, 0th index. Starting with 0 points, you want to maximize the number of points you can get from the matrix. Okay, number of points. However, to gain points, you must pick one cell in each row. Picking the cell at coordinate RC will add points RC to your score. Okay. And from each row, I have to pick one. However, you will lose points if you pick a cell too far from the cell that you picked in the previous row. For every two adjacent rows R and R plus 1, where R 0 and minus 1, picking cells at coordinates R C1 and R plus 1 C2 will subtract from your score. Oh, interesting. So okay, return the maximum number of points you can achieve. Absolute x is defined as x squared. So what it means is what this means is if I so there is 1 2 3 1 5 1 and 3 1 1, right? So what it is saying is we can gain point. You must pick one cell in each row, so I have to pick one cell in each row. From every row I have to pick one cell, and if I pick a cell too far from the cell that I picked in the previous row, so suppose this is the cell and suppose this is the cell, then it will subtract, this will be subtracted 1, you know. So if there was if I picked a cell from the first column on row 1 and like fifth column from row 2, then it will be 5 minus 1 is equal to 4. Okay, so there will be 4 subtraction. That's what it is saying here. Okay, so okay, so I lose every point if I move one cell above. So it means that I have to make sure that the points that I lose is less than the points I gain. Okay, so for example, from this point I can select 3, right? Because 3 is the highest. So this is 1 2 3, this is the highest, and from 1 5 1, this is the highest. So I can select this 5 because this is the highest. 3 1 1, I can select this because this is the highest. Though I will lose 1 point, but it is still worth it because if I choose this and this, then it will only gain 1 point, but if I choose 3, then it will be total of 2 points actually, because 3 minus 1 is equal to 2. I need to say the total point minus points lost. That is the net point. This is the net point, right? Point of the cell minus points lost by traversing columns. Okay, so in this question, this is easy, right? 5 is 3 and this is 4 4 5 6 7 and 8 9, right? This is the point. First index minus second index, that's what they are doing here. And in this point is 5 3 and 4. Here also it will be 5 3 8 and 8 plus 3 in 1911. Okay, so what is the complexity in this question? The complexity is to find the highest value first, right? And the m and n can go until like 10 to the power 5, so there might be so many columns, so I cannot just pick the highest number. I have to make sure that the difference is worthwhile. So how can I do that? I don't know. Suppose if this was the biggest is 5 here, and here the biggest is 8, and here the biggest is 9. Suppose this at 11. Then what would I choose? Would I choose 9 or would I choose 11 here? So this is 9, so is this a like backtracking problem or some kind of recursive solution? I just don't like those problems, where you have to look at all the possible use cases, all the possible ways that I can do it, because I cannot just say that okay I'll choose 8, right? Because there is 11 here, so maybe I can just choose 5, because choosing 5 and choosing 8 is similar. So if I choose 5, then it will be, when I go to 8, then it will be same, right? So suppose I just add this 2. Okay, I just add this 2. So if I choose 5, then, so suppose if I choose 8, then it will be 8 plus 11 will be 11. When I go to 8, 8 10 9. So this, when 11 comes up to 8, then it will be like 11 10 9 8 7, right? So it will be 8 plus 7, answer 7 14 15. But if I choose 11 directly here, then 8 7 6 5 4, so it will be 11 plus 4 15. Oh, so looks like the sum will be same always, even if I choose this way or that way, isn't it? 11, but what if there was like 11 here, then here there is no point of choosing. What I'm trying to do here is, from every cell how will I know which point to get? Oh my god, why am I taking so long to find a solution? Okay, so please, brute force is fine too. Just do brute force if you cannot find an optimal solution. Okay, so let's think of brute force. So 1 by 1 148. Let's create more examples, right? Let's create more examples. Like what if um it's 12 and then this is 4. Then in the first one I would choose 12, and then the second one I can choose 11 here, because 11 is just far away from, because I can see that all everything is 11 here, and then I know that I don't have to choose this number. Or maybe if this was like 19, then obviously I would have chosen this number 19. So does this mean that I have to choose the biggest number here in the first row? If I choose the biggest number, in the second number, whenever, if it is 19, then I will know that okay, this is 8, this is smaller, so 18 is the biggest. If I go right, then this is 17, 17 is the biggest. I go right, then 16 is the biggest. I go right, then 15 is the biggest. So if I just choose a position, whatever position I can choose from the first row, then the second row would be, I can start from the beginning and then go until this point and see if that is fine or not. So suppose if this was I, then I could have gone until this 14 point, okay, and then uh, and then I'll just compare with 14 and 1 minus 0 and then 14 and 4 minus 2, so things like that. So then that is fine. So if I know what number I want in the first row, then it is easy to know what number I want in the second row, right? That is easy. But is it always fixed that okay, this is the number that I want in this one row, in my first row? According to this, it did not matter if I chose 8 plus 7, you know. Because I think that first row is always a, what I'm trying to say is, okay, so this is clear, right? Once I know which column from the first row, I know what column to choose from second row. But each is this what column to choose from the second row, is that always fixed? Does it matter if, what if, but it should all, I mean, should I always choose the biggest number? What if I choose not, I don't choose the biggest number, and that give me the so suppose this is 8, so this is 7. 7 is the biggest number, and if I choose 7, then it will be 11, 10, 9, 8. So it will always be 7 plus 8 if I choose 7. But if I choose 5, then it will be 5 plus 10. 8 plus 10, 15, 5 plus 10. But looks like the sum will always be the same, even if I choose that or this, right? Because if I choose 7, then what if this is also, what if this is 10? If I choose 7, then it means that it will be, so suppose 7 is here, okay? So if I choose 7, then it will be, if I choose 7, then it will be 7 plus 8, 10, 9, 8. 7 plus 8, yeah. But I will choose 7 plus, oh, why is it always coming up? Maybe I can say this is 12. I just want to create a scenario where choosing a number in the first row which is less than the highest number will give me the optimal solution. I just want to choose that, because if I just choose the biggest number and then choose it accordingly, then it will be easier. This question will be easy. I'm just trying to create that scenario. 1 5 6 1 7 11 8 12 3 1. Oh my god, I was distracted, sorry. 1 5 6 1 7. What is the time? 11:31. I need to do it quickly. 1 5 6 1 7 11 8 12 3 1. So I have a one concurrent viewer. Okay. So Marisa, I'm a little bit nervous here because I thought that I was just doing everything by myself and just alone. But no, there is one viewer who is watching as I'm speaking. So I'm a bit nervous, but it's okay. So let's see. Is there a like? Does it always have to be? What I was saying was, in the first row, can I just select a number that is less than the biggest number? Yes, right. Like suppose, just imagining, and just instead of just writing this, it if I imagine, then it is easier, right? So if suppose there are like a lot of columns, then just selecting a smaller number can be can be near the biggest number, right? It is, I think that it always depends on the distance. So if that number and the highest number, if the difference is just very small, then suppose that the number that I selected is in the left is, and the number that is the highest is at the foremost is, then even the number that I select, there might be a big number. Suppose if I select 5, and there might be 119. So 119 plus 5, it will be, right, the sum. But suppose if there is 6 there, and if I have to select 119, then it will be 119 minus that column, right? So yeah, it will be 6 plus 119 minus that column's name. So actually always selecting the highest number in the first row is also not good, I think. Yeah. Yep. So what should I do then? Like, if just selecting the highest number, so how do I know which number to select? Should I just, is this a recursion problem where I just find all the possible solutions? and select the highest number, like a dynamic programming. Because when I try to do it with greedy approach, I don't think that is good. Just selecting one and then selecting the best solution from the second, selecting the best solution from the third. This is not a good solution. Actually, when I'm considering this problem, I'm just thinking about two rows. I don't have to like think about multiple rows, because just two rows is enough. I just have to make sure that I select such two numbers from those two rows whose sum is the optimum. So how can I select two numbers from two rows whose sum is the biggest sum? And I'm also considering the column distance. It's just like, yeah. So that is the thing. And like I said, I cannot just select one number. So let's look at the editorial, because I do not have much time here. Dynamic programming, okay. Our goal with this problem is to determine the maximum number of points we can get, because I think that I already spent like 14. I started from like 11, 16, 26. I already spent 20 minutes, so I don't want to give more than 20 minutes. Our goal with this problem is to determine the maximum number of points. So actually, dynamic programming, let's first see the approach. Dynamic programming and to dynamic programming optimized. So this is a dynamic programming problem, like I said, right? Because you have to find all the solutions. Yeah. So this is a kind of problem that I just do not like solving. I mean, maybe if I continue, if I have a lot of practice, or if I solve like 4-5 questions with dynamic programming, then maybe I'd be comfortable with these questions. But now that I'm just beginning, like as soon as I found out that okay, this is a dynamic programming problem, I do not want to look it more. But that attitude is not nice, and this attitude will only go away if I keep on practicing. So I'll just keep 2 more minutes to see how I can solve this with dynamic programming. Okay, I think that what I can do is just think that okay, this is the number that I'm selecting from the first number, and this is the number that I select from the first number, this is the number that I select from the second number, this is the number that I select from the, so just because what I was thinking in greedy solution, I was thinking that I will only in the greedy solution approach that I thought, which did not work. I thought that okay, this is I will take the highest number first, and then if I know if I once I know a number that I'm going to select in the first row, then it is easy to find a number which I want to select in the second row, right? And once I know okay, this is the number that I select, then it will be easy which number to select, right? So I can just that is how I can optimize the dynamic. So there are two things. One is one is one is not just the highest number. I have to do it for all the numbers. Okay, I have to start from 1 and see what is the sum. If I start from 1, I will start from 5 and see what is the total sum if I start from 5. And similarly, and that is a dynamic problem solution. And then another, to optimize it, what I can do is I can just put on a cache, because suppose if there are so many rows, then so suppose from 12, okay, suppose from 1 I chose second as 12, then I will already know from 12 what will be the sum if I choose from 12, right? So I can just store that, so that from 7, if I chose to store from 12, then I do not have to compute it again. So is that a solution? Yeah, this sounds good. So I just told you the basic approach, right? So I still have one concurrent viewer. Is this I think I is this pizza lover who I know. Okay, so that was my dynamic approach solution. I think that will work. Yeah, from every number I know that. Okay, if I select this, then there will be one definite number, right? So that is actually a good approach. That is actually, I mean, this is actually a like straightforward solution. Once I know, okay, this is the number, then it is straightforward uh, to know what is the total sum. This is the number. Okay, so let's look at the solution. Our goal with this problem is to determine the maximum number of points we can get by. Should I code this? I just do not have time. I just do not have time. Otherwise, I could have coded this. So let's just think about how I can code this solution. So 1 5 6 1 7 11 8 2. So 1 6 1 7 11 8 2 1 3. What I could do is I can just start from the bottom row. Okay, yeah, that's what I would do. I think if I could just start from the bottom row, and then for every position I can just say, okay, this is the maximum sum, and then go upwards. So suppose if I start from 11, then either and go down, then 11 would be the highest, right? From 8 will be the highest. From 12 3 1. And then if I go from 1, then if I select 12, then it will be 12 plus 1. If I go from 5 and select 12, then it will be 12 plus 5 minus obviously this as well. So I mean, for every position I'll just save the total sum I can get from that position, and then once I go upward, once I try to compute the cell for the row up, or from for the upper rows, I can just use the computed sum. So that's what I'm thinking of how I'm going to code. So let's overview. Okay, so let's go to the solution. Our goal with this problem is to determine the maximum number of points we can get by picking one cell. Possible score, okay. Penalty equal original distance between the current cell and the selected cell. The possible constraint, it may be useful. Best time to build, buy and sell stock, and 1014 best sightseeing pair. Okay. These problems involve similar concepts of optimizing a series of decisions or transactions, which is a key aspect of solving the matrix points problem efficiently. Understanding the strategy used in those problems will build a foundation for approaching this one. I think I did this problem. But I have not seen this problem. Dynamic programming. Create a solution that efficiently finds the maximum points possible while moving from top row to bottom row. I just want to see the optimal solution. Okay, let's see this. In the previous approach, we used auxiliary arrays to keep track of the maximum points achievable from left and right directions. This time, we streamline the process by using the current row array itself as it's not a winner but a warrior. I, I jumped to optimized solution, but let's see, because looks like, I mean, the optimized solution is just a little bit optimization of dynamic this one. So just to understand the concept of how they are applying dynamic programming, we can look at this. Our goal is to create a solution that efficiently finds the maximum points possible while moving from top row. To do this, we initialize an array called previous row with the values of the first row of the matrix. We can then operate off this array to build another array, current row. Oh my god. To do this, we initialize an array called previous array with the values of the first row of the matrix. We can then operate off this array to build another array. Oh, I mean, this is exactly how I thought I would do. Oh, I'm looking at, so I can see the road in front of me, and I just saw such a cute view. Oh, and I got distracted. Sorry, guys. But the view was there is a like pair of father and two small kids, and they are all cycling. They're crossing the road, and it looked so cute when those two brothers were helping each other in the cycle. And then this area is really a posh area. I can see so many like posh cars in the road. Like some are convertible, some are like I can see Lamborghinis sometimes. So yeah, the view from my window is really nice, and there's greenery, nature, and everything. Okay, moving on. I think the solution is how I thought I should close my window before starting to do LeetCode solution, because it is really distracting. Like whenever I see something so beautiful, then I do not want to miss that, so I think, oh, there is a convertible there, and then it is and then there is a dog, white puff dog. It is sitting like a king. Oh, I should really close this window. Let's really do that. Now that I do not have any concurrent viewers, so I'm free to say whatever I want. So this is my concurrent viewer. Looks like they left after I started talking gibberish. Okay. Our goal is to create a solution that defines the maximum points possible. So yeah, previous row with values of the first row of the matrix, and then each element in the current row will represent the number of points we can gain by picking that cell, taking into account both the point cell and picking penalty for choosing it. With the iterate over all the cells in the previous row and apply the penalty. Iterate over all the cells in the previous row and apply the penalty for the original distance. So build current row would be to iterate over all cells in previous row and apply the penalty for the horizontal distance. Previous row j minus, yeah. Since this ability checks every cell in the previous row for each cell in the current row. Yeah, for each cell in the current row, it checks everything, right? Given that we need to repeat this process, the solution would not meet problem constraint. So instead of recalculating possible scores from every cell in the previous row, for each cell in the current row, we can use actually left max. And so yeah, so this is just about calculating the scores in my current row, because like I said, right, for every row I need to calculate which one is the maximum for this one. So yeah, then this was the solution that I thought. For every point I can just start from 11, and then yeah, but my solution was not good. So this is the solution that I thought, but instead of this, it looks like there's a better solution. For each cell we can use two auxiliary arrays, left max and right max, to store the maximum possible contributions from left and right stream. Left max and right max. Oh, actually I did that. I was thinking of left max and right max, right? Because, and that's what I was thought about. From 11 I can just go on and then look at, okay, so this is the maximum value, and then it will be 9 here, it will be 12 here. So that's what I thought. This allows us to simply compare this pre-computed value to determine the basis for each cell in the current row. No, this is not my solution. So simply compare these two pre-computed values to left max and right max. So for every point I need a left max, and for every point I need a right max. So set left max to previous row 0, then for each subsequent index compare left max at the maximum of the subtraction. Yeah, that's what I'm saying. I mean, two indices to consider: previous row I and left max I minus 1. Similarly, construct right max by iterating from right to left. So with left max and right max prepared, we can compute the maximum points for each cell in current row. So maximum of left max and maximum of considered in 0 to I minus 1. The previous array will contain the maximum possible points for each cell in the last row. So this array previous row will contain the maximum possible points for each cell in the last row. Yeah, that's what actually, and this is my solution. The final array is the maximum value found in this array, which represents the highest score achievable while moving from top to the bottom of the matrix. Yeah, this is exactly what I thought. It combines the right side information with the left side maximums. Yeah, actually this is what I did here. If you look at the video replay, then this is what I thought did. From left I calculated the left maximum until that point, and after that point I tried to go from the right, and then just calculate for that point which one is the maximum. For each cell I, we update current row I to the maximum of its current value and the maximum points from the right. This is done by, actually I just remember that I still have to do one question, but it's okay. I know that. Why am I so distracted? Like, I need to go from left, right, left, right, left, right. As we may move leftward, we update the current value in current row I with the current row I with the maximum of its own value. We initialize the right tracking at the last cell, and as we move leftward, we update the current value in the current row with the maximum of its value and the right side maximum as it stands. Finally, we add the point value of the current cell in the points matrix to current row, ensuring that it reflects the maximum points for that cell. After processing all the rows, the array will contain the maximum that came in for each cell in the last row of the matrix. Yeah, and the maximum value of this array is our final answer, representing the highest possible score. Let's set columns as the number of columns in the points create current row and previous row of size columns and iterate through each row in the points matrix. Initialize a variable running matrix to 0, and from column 0 to column -1 update running maximum to maximum of uh, running maximum -1 and previous column. Set current row column equal to running max, and then now iterate column in the reverse order. Update running maximum to the maximum of running maximum -1 in previous column, and then update by taking the maximum of current value and update previous row to the current row, and loop through all the values of previous row and set maximum points to the maximum and return maximum points. So yeah, so first of all, running max holds the maximum value generated in the previous iteration of each loop. Okay, and this is left to right pass. Right to left pass. Update previous row for next iteration. This is column is equal to 0, column is column minus calls plus column running matrix. Just copy this and then Java list. Try to submit this. I just do not want to lose a strip. This is not a good way to do it, but this is what I do, because if I know that I'm maintaining a streak, then it will encourage me to do it tomorrow as well. So just for encouraging me, I'm doing this. It's copying listing. But I think I was really close to the solution. This is what I thought about as well. I was just taking one row each at a time and then looking at other row. And for every row, for calculating the highest number, that's what I was doing here. You know. So yeah, so the dynamic dynamic programming, it is just about reusing the previously computed value, right? This is doing the same thing again and again. So there are two things. One is, can I reuse the solution? One is, can I generalize the solution? Can I do the same computation? Can I use the same um, same solution to compute for this one like I did for that one or not? And can I use the sub solutions to generate the solution or not? So for this problem is, because for every cell, to find the maximum value for that cell, it was the same approach. So there is generic solution for every, right? And then also this was about using the previous solution to find the current solution. So that is why this is a dynamic programming problem. And obviously dynamic programming comes up when we do not have a greedy solution, a solution that we can find in just one pass. But in dynamic programming, it's like we have to calculate so many multiple solutions and find out the best solution, kind of thing. Oh, those peers of father and those two kids, they came up again. They're crossing the street that way. Now they are coming back. They're so cute that I forgot this problem. Not cute. Anyway, left to right pass, right to left pass. They're also doing current row column maximum also. Yeah. I I do not like that I did not code this problem because I could have done it properly. So I just feel like I do not want to go. I do not want to let go of this problem because I'm so close to the solution, but I did not code it, and I feel like if I had coded it, then I might have come with exact this code. And it's funny that I said that I did not have time. I knew that I had to go at 11, leave at 11:40, but I still am here and I did not even solve this. So that's okay. So I'll just recap everything so that I can let go of this problem. So yeah, so this was my solution, right? My solution was just to compare two rows, just to get from one row. First of all, get all the maximum values, because actually first row is, yeah, think because the first row is just the values only, and from second row I will use the previous row to get the maximum value. And for that, for every row, like I said here, I had to oh, this is where I did it. Yeah, that this is where I did it, right? So if this is 19, then if this is the column, then what happens is this 19 will become 18, 17, if it is 18 will become 17, 16, 14. So this will be 14 here. And from right also I was doing this, and I thought that okay, this will be I'll do maximum of 14 minus 2 here when I go from the right pass. So this is how I'll find the maximum. I think they are also doing the same thing here, similar approach. For every columns they are doing, not just for one, but for every columns they are doing this. See, if col is equal to 0 and col minus columns, right? So integer row points, this is the current row and this is the column, this is the running max. Okay guys, thank you so much and bye bye. From my next lit code, I should make sure that to not get overwhelmed by anything. If I see any dynamic problem question, then don't get overwhelmed, because everything is intuitive and nothing is so difficult. Just like 1 2 3 steps, just take hints if you want, like I did here, right? I just saw, okay, I thought that okay, this is a dynamic programming solution, and then I took in it, just looked, okay, this is dynamic programming, and then I thought about the solution, and then I looked at the and then I thought about this is how I'll code it. But my solution to me is, don't just stop there, but just write at least pseudocode or write full code or do something. Don't just leave it there, because what I did today, I just thought about, it was not clear, it was big solution, but I will not progress just by coming up with a big solution. If I want to progress more, then I have to come up with a, like, I have to dig deeper, I have to make that big solution clearer, because maybe I had been missing so many things in my big solution, so if I do not concretize that solution, then I'll never know what I thought was wrong, or I never know what I had to learn. So yeah, this is my takeaway. And but I cannot even keep this takeaway to myself, because I always assign 21 minutes, and otherwise I look at the solution. So maybe I should increment the time from 21 minutes to 30 minutes. So only if I do not solve within 30 minutes, then I will look at the solution. Okay, so this sounds good. Okay, namaste, bye.